talk about rare earth elements, or for the sake of this video, we're going to call them rare earth metals. Rare earth metals are essentially just all the lanthanides. They're called rare earth metals not because they're not found on the earth's crust, but it's because to extract it, it's pretty difficult to get a high yield of it. Rare earth metals are used in the glass industry, the battery industry, and the electronic industry, just to name a few. China is the leading producer of rare earth metals. It's not that other countries don't have reservoirs of it, it's just that they don't have an established means of production. In India, there are around 6 million tons of it present in reservoirs. A lot of it is pretty much found in the northeast. Today we're going to look into, well, Sung Valley. And we welcome you to Sung Valley.
Socio-economic situation. Mining companies nowadays need to go simply beyond identifying technical and security risks to their operation and instead make sure that they are fully aware of the social and environmental risks. Failure to properly account for such risks can mean that mining operations may face regular protests, closure, or failure to set up their operations. Some may even lose the viability or control of their mining projects. The Sung Valley cradles between the West Jaintia Hills and the East Kashi Hills district of the state of Meghalaya. It is a bowl-shaped depression covering an area of about 26 kilometers square. It is the most studied carbonatite complexes in the Shillong Plateau. The valley is famous for its black clay pottery and for the many types of rice that grows here. In fact, the Sung Valley is called the rice bowl of Meghalaya that feeds families all over the hills. The locals say that the Sung Valley is so fertile that whatever you grow here flourishes, be it vegetables, fruits, herbs, spices, or hazelnut trees. Their livelihood here is mostly based on agriculture, pottery, and sometimes fishing. For generations, these families have kept alive the tradition of terracotta pottery. The strong sense of community might make it difficult for them to be compensated and relocate to make pay for the
One
project.
method of extraction that we suggest is phytomining, where we essentially depend on plants to do all the heavy lifting for us. It involves three steps essentially: growing of the plant, mass reduction, and extraction from the organic matter. The plant that we suggest is the fern. Now, the fern is a hyperaccumulator. It essentially means that it absorbs all the metal that's present in the soil and accumulates it in its roots, stem, and leaves. Now, why the fern? The fern matches the growing conditions of fern matches the climate in Meghalaya, and an added bonus is that it has the highest accumulation in terms of rare earth metals per kg of organic mass. Now, once a plant is grown, we need to reduce the mass. Now, mass reduction happens in three options rather. One is cryolysis, where we heat or burn in the absence of oxygen, composting, where we degrade the organic matter, and combustion, where we just burn off all the organic matter. Each of this has its own pros and cons. What we suggest is use them all sequentially. Cryolysis for the initial reduction in mass, composting to increase the quality of the mass, and combustion to eliminate all the organic mass that might be present. Now, one of the major advantages of this is not only that we get a high concentration, high quality of rare earth material mass, but the byproducts include biogas, bio-oil, and biochar, which can help make this entire process self-sustainable. Now that we have the organic mass present, we need to extract it. There are two main methods of extraction: chemical leaching and hydrometallurgy. Chemical leaching essentially you digest the mass with water, basic salt, and an acid, and the rare earth metal precipitates out. Hydrometallurgy is more often used. It involves four steps: leaching, where you dissolve the entire mass in uh, one dilute base and two dilute acids. Solvent extraction uses the same base and the same acid, but of a higher concentration. Ion exchange is the next step and is used only if the organic mass has a low concentration of rare earth metals. If all goes well, then the rare earth metal will just precipitate out and we have a high concentration, high quality amount of rare earth metals.
Microbial extraction. There are sustainable and environmental friendly methods for extracting rare earth elements. One such example is the bioleaching. Bioleaching leverages the metabolic activities of microorganisms such as gluconobacter oxidants to selectively dissolve and recover these valuable elements. They produce gluconic acid, which shows the maximum leaching potential. The solubilization of metal from their ores is based on three mechanisms, namely acidolysis, complexolysis, and reductolysis. These are the three reactions for these mechanisms. Bioleaching requires certain optimum conditions to be met. They are an adequate supply of oxygen, pH value less than 5, optimum temperatures of 28 to 30 degrees Celsius for mesophilic organisms, high tolerance to heavy metals such as nickel, copper, zinc, availability of substrates such as ferrous sulfate in the solution, particle size of 24 micron is regarded as optimum for bioleaching activity. These have to be present in the reaction mixture for optimum extraction to occur. The leaching medium contains microorganisms, nutrients and acids which is pumped to the body of the ore. Here the pregnant leaching solution is then taken out and is sent for metal recovery, from where we will get the pure rare earth element.
Okay, so coming to gang materials, what we have is the practical uses as well as the industries. So first we have calcite, which is used in the production of cement and concrete and acid neutralizing soil treatment. Then we have dietary supplement in animal feed, mine safety dust, tablets that neutralize stomach acids, and yeah, then we have dolomite. So the first 2 points are the same as calcite, and it is a source of magnesia. It is used as a sintering agent and flux in metal processing, production of glass, and in ceramics. Then we have apatite, which is the source of phosphate. It is used in fertilizer production. It is used in the production of phosphoric acid used in food additives, beverages, and detergents. It is used in gemstones, and it is used in the study of crystal growth and chemistry. Next, we have magnetite, which is used in steel manufacture, Haber's and Fischer-Tropsch processes. It is used as nanoparticles, ferrofluids that are used in drug delivery and water purification systems, and finally in ceramics. Now we have the industries, which are Gangotri Enterprises, Bell Metal Industries, as well as Shiva International. Now we have mineral carbonation, which includes, of course, the process and the cross section of the mine site. Now, mineral carbonation is a process used to convert gaseous CO2 into its stable form. First, the mineral goes through crushing, grinding, and screening, and in the case of serpentine, magnetic separation and heat treatment. So the process utilizes a slurry of water with bicarbonate and salt additions, mixed mineral reactants such as, olivine, serpentine, and pyroxene. So carbon dioxide is dissolved into the slurry, resulting in dissolution of the mineral and precipitation of magnesium and carbonate. The specific conditions are given here. And under these conditions, 78% of the conversion was achieved in 30 minutes. So the product consisted of magnesite, free silica, and residual silicate, and it can be used for soil amendment. And free silica may actually help improve soil water retention. Now, we have the cross section of the mine site. Over here, you can see that there is peridotite, pyroxenite, as well as carbonatite. Now, carbonatite is used for REE ore extraction, whereas peridotite and pyroxenite are used for carbonation and carbonation, basically. So, pyroxenite is composed of pyroxene, while peridotite is composed of olivine and pyroxene.
The effect
Now
of
we have
mining. For every ton of rare earth metal that's produced, there are 2,000 tons of toxic waste produced. The two primary methods of mining rare earth metals is removing the topsoil or by drilling holes into it. Both these processes are very water intensive processes. That means that the groundwater surrounding this area is generally contaminated with radioactive waste. This radioactive waste carries on through the wildlife and plants that lives around there. That means that anything that does drink this water ends up being filled with toxic waste. Another thing that you need to take into consideration is that, well, mining in general creates a lot of dust. Now, this dust can cause cancer, and the dust also falls under the category of small particulate material, which is very dangerous for people who work at the mine and who work around the mine.